So now we are going to discuss about second important component, which is matrix. This is going to be a very important factor, and we have already seen while working on vectors that we can even create a matrix or define a matrix with the help of row vectors and the column vectors which we have created. Now if you recall, we our matrix is going to look something like this. So we have like 1 2 3 4 5 6, and if you look at this have rows and this have columns also, right? Now what is a row? Rows are going to be in the horizontal format. So when I say rows, this we gonna count it in the horizontal format. When I say column, basically I'm talking about this part now. So column is basically going to come in the vertical format. So this is going to come from the vertical format. Entities entities is individual data, let's say 6, right? What you have here. Dimension. Now how many rows are there? 2. How many columns are there? 3. So 2 cross 3 is the dimension of this particular matrix. Similarly, we have few more terms. For example, there is something called a square matrix. Now when I say square matrix, it basically means that I have same number of rows and same number of columns being available to it. Similarly, we do have something called as diagonal matrix. Diagonal matrix. Diagonal matrix basically means that we have in the diagonal elements we have all the values as 1, and remaining all the places we do have 0. That is basically called as diagonal matrix. Similarly, we do have an identity matrix. Now in identity matrix, basically also we have all the diagonal elements are going to be 1. So basically here what's going to happen, what's the difference basically with respect to diagonal matrix? So this is actually, you can exactly determine it as identity matrix. Now in the diagonal matrix, when I say, right, now only difference is that instead of 1 I could have 2 also, means any other element other than 1 is also possible. Only thing is that at the non-diagonal elements we're going to have 0. So that's basically the difference which is going to come with respect to your diagonal matrix. Now what I want to do is, let's go back to Python notebook. So in this section we're gonna play with Python notebook a lot. So let's go back to Python notebook and let's do create some sort of matrix here. So let's say I'm gonna have x is equal to np dot basically here I can, instead of saying this, I can directly say matrix. Okay, and np dot array we can say matrix. So now in this case I'm gonna keep some values. So let me start keeping it here. So it's a two-dimensional 1 2 3 4. Okay, so let's say 3 4. I'm gonna keep the data like this, comma, let's say 5 6 7 8. Okay, this is another set of data, comma, let's say after that 2 3 4 5. Okay, and let's add one more, comma, let's say 6 7 8 9. Let's execute it. So this is my x, right? If I print out the value of x, you can see that it's now showing up very nicely. Now if I ask you that, can you tell me what is the dimension of this matrix? So you can always say x dot shape and it will tell you up that it's a 4 cross 4 matrix. So this is how, using Python, you can always go and even get the values of all these things. Now similar to this, you can perform multiple other operations on your matrix. For example, you can perform matrix addition, like if you have a matrix A. So let's say if you have a matrix A which have 1 2 3 4, and I have a matrix B if it have 5 6 7 8, and if I say A plus B. Now one very important thing to look at is that they both should have similar dimension in order to have this addition being possible. So like in this case, this is a 2 cross 2 matrix and this is also a 2 cross 2 matrix. So I can always add them up, like 1 plus 5 is going to be 6, 2 plus 6 is going to be 8, 3 plus 7 is going to be 10, 4 plus 8 is always going to be 12. So this is how you can get the summation of this. But if in case the dimension of B was not 2 cross 2 but 3 cross 2, we would have got an appropriate error. Then this would have not worked. So similarly, this is your addition part where we have such restriction. Now, if we talk about matrix multiplication, matrix multiplication. Now, in multiplication, we do have a small difference. In multiplication, let's say I have two matrices. One is A. Let's look at the dimension of this A. Let's say this is A1 cross A2, and let's say I have B matrix for which the dimension is B1 cross B2. Now, if I want to multiply these two matrices, this is only possible, means if I want to particularly solve, let's say A cross B, this is only possible if my A2 is equal to B1, means this two values should be exactly similar, otherwise it is not going to work. Similarly, think about it, if I have to do B cross A, then what should be the similarity? Think about it for a minute. So here, if you have correctly done it, it should come out to be B2 is equal to A1. Just to give you one example, let's say I have a data like 1, 2, 3, 4, 5, 6, and I have another matrix which is 1, 2, 3, 4, 5, 6. Now if you look at the dimensions of this is a 3 cross 2 and this is a 2 cross 3. Now I can see that these two elements are similar, so this multiplication is definitely possible. But let's look at another example where let's say I have data like 1, 2, 3, 4, 5, 6 multiply by, let's say 1, 2, 3, 4, 5, 6. Now in this case the dimension of this matrix is 2 cross 3 and this is also 2 cross 3. Now 3 is not equal to this 2, so this multiplication is not possible. Okay, now in your machine learning problems, when you are going to solve this, all this matrix multiplication will be done by your computer itself. But it is always useful to know the size of your input and output, because if let's say you plug in or you input some matrix which is of wrong dimension, which is not expected, you may end up with errors. So it's always a good idea to know about these dimensions, but later part multiplication will be done by the computer, so you need not worry about it. But we're gonna definitely learn that how do we can compute this multiplication of matrix and so on. Now as I said, this is all completely dependent on the dimensions if you want to look at the additions or matrix multiplication. And you can also basically design your data processing pipeline more efficiently if you have the knowledge of your dimensions. Now let's look at that how we can basically do this sort of multiplications. So let's say I have a matrix like 1, 2, 3, 4, 5, 6 multiply by 7, 8, 9, 10, 11, 12. Now you may ask me a question whether this multiplication is possible or not. So you can say 2 cross 3, this is 3 cross 2, these two are equivalent, so that means we can multiply. Now let's see that how this multiplication can be taken place. So I'm going to tell you the first term, that how we can get it. So the first element of this will be multiplied with this. So I will say 1 cross 7, okay, plus. Then 2 into 9, 2 into 9 plus 3 into 11, 3 into 11. This is how we get our first term, and if you count it up, it will come out to be like 158. Similarly, if I have to get this part, right, this part, so the output is going to be like, since it was a 2 cross 3 and 3 cross 2 dimension, so you're gonna get the output like 2 cross 2 dimension. So what will be this dimension now? So I would say 1 into this 8 now. So 1 into 8 plus 2 into 10, 2 into 10 plus 3 into 12, 3 into 12. Now let's get this. Similar way we will look at this matrix now. So 4 into 7, so 4 into the first term plus 5 into 9 plus 6 into 11, and then after that with this 4 into 8 plus 5 into 10 plus 6 into 12, like this. Okay, so this is how you can get the multiplication of two matrices done, and you can always get your output. Now let's basically do the same thing with the help of Python. Okay, let's go back here and play with this Python notebook to see that whether we can even perform such things here or not. So let's create a matrix. Okay, so I would say A is equal to np dot let's create a matrix itself, matrix. I'm gonna keep the values like 1 comma 4 comma 5 comma I can put some more values, 2 comma 4 comma 3 comma 5 comma 6 comma 8, means any value you can keep. I'm just randomly keeping up. Since it was in dimensions, I should have added one more bracket here so that it would have make sense. Now if you look at this matrix A, this is gonna look like this. Now let's define my second matrix, np dot matrix, and if I want to define it here, I can say 2 here comma 4 here comma 5 here. So I'm gonna plug in the value 5 here, right? Now let's execute this and look at this matrix also. We can see that this is the output. Now you can see that this is a 3 cross 1 and that is a 3 cross 3. So since 3 and 3 are matching, we can definitely do the multiplication. But before that, let's look at the dimensions of it. So a dot shape is going to give me dimension of this. This is going to represent me this. So I can see that 3 and 3 are same. So we can always do that. Now if I want to do the matrix multiplication in Python, we can just say print of A into B, and you can see that this is going to be the output what we're gonna get, right? So this is quite a simple way how you can always go back and can basically create all these things in your Python notebook. Let's look at another factor called as transpose. How we can perform a transpose and what is this transpose? So let's say if you have a vector like this A, B, C, D, and if I have to get the transpose of this, what happens in transpose? We make the column as rows and rows as column. Means now I'm going to make it A, B, C, D. Just change their things, and this is basically what is the transpose. Now how to basically get how this is going to be useful. In fact, you're going to see a lot while working on uh, basically on this machine learning part. You will notice that there we're gonna use this transpose actually a lot many times. Now this is about how you can basically work with respect to some common operations being present in matrix. Now there is one very interesting property basically what comes with respect to this matrix component basically is that this follows a very interesting property. If you have to if you have two matrix being given, let's say this L is just like a function, and if we say V plus W, these are let's say two matrix. So if I get this sort of rule being coming up, this is also called as additivity, or sometimes we also call this as distributive property, okay. Similarly we do have another property from matrix. Let's say this is C cross V. C is a scalar value, so I can always say C L V. Okay, this is also called as associativity. Okay, so just keep this in mind because this other terms we sometimes use a lot, so you should be aware of that how you can use it. Now let's say there is an equation something like this. There are three equations which I'm going to create. So 5 cross x1 plus 4x2 plus 8x3 is equal to 10. Now after that we have 3x1 plus 9x3 plus 8 is equal to 8, and similarly 3x1 plus 4x2 plus 2x3 is equal to 5. Now how I can represent this thing into a matrix and can work on it. So my matrix is gonna be like a 5 4 8 3 0 9 3 4 2. These are the values which I can represent in my A. What is my x? X is going to be x1, x2, x3. That means we have three unknowns basically what we have. And what is my output B? Output B is 10, 8, 5, and this is what we have to solve. There will be three equations, three unknowns, and we can very easily kind of get our output from this particular format. So you can always basically get your outputs while you are solving this sort of problem. Now when you are working on this, basically since this is multiplicative and all, you can always have to follow these properties which I have defined before, like associativity, commutativity. So you have to keep all these properties also in mind. So let's do one thing. Let's talk about few more terms present in your matrix from next lecture.